Hello everyone. Today we're going to get into some actual non-right angle triangle trigonometry. But before we begin that, we'll just go over the assignment from last class, starting with 1b. This is our reference angle, this is the opposite, this is the adjacent. We need to use tan, put 32 in for the angle, 43.6 is opposite, x is adjacent. We need to multiply both sides by x first, and then divide both sides by tan of 32. And 43.6 divided by tan 32 gives us 69.8 centimeters. For 1c, this is our reference angle. We have the adjacent side length and the hypotenuse side length. We need to use cosine, so put 42 degrees in there. X is the adjacent, 16.5 is the hypotenuse. We need to basically multiply both sides by 16.5. So 16.5 times cos of 42 gives us 12.3. For 1d, this is the reference angle. We have the opposite side length, and we have the hypotenuse side length. 52 goes in for the angle. 129.3 is opposite, x is the hypotenuse. We need to multiply both sides by x, and then divide both sides by sine of 52. And 129.3 divided by sine of 52 gives us 163.7. On to question number 2, where we're finding angles. X is our reference angle, 18.4 is our adjacent, 24.5 is the hypotenuse. We need to divide 18.4 divided by 24.5. That gives us this number, and then we need to take the inverse cos of that number, giving us 41.3 degrees. For 2b, this is our reference angle, this is opposite, this is the adjacent. We need to use tan if we have opposite and adjacent. 3.8 is opposite, 4.5 is adjacent. Do this division, it gives you 0.84 repeating. We need to take tan inverse of 0.84 repeating, and we get 40.2 degrees. And for 2c, we have the opposite and hypotenuse. We need to use sine. So sine of x is opposite over hypotenuse. We do this division. It gives us 0.681 and some other digits. And then we take the inverse sine of this number, and we get 43 degrees. That's angle x. And last 2d, we have this is our reference angle, opposite and adjacent. So 124.6 is opposite, 112.4 is the adjacent. Do that division, you get 1.108. Take the inverse tan of that number, and you get 47.9 degrees. So now we're on to sine law. So using the trig ratios sine, cosine, and tangent, as well as Pythagorean theorem, you can solve for missing side lengths or angle measures of only right angle triangles directly. But what happens if you want to know a missing measurement from an oblique triangle? So in other words, a triangle without a right angle. So the first thing we're going to do to tackle that problem is the sine law, which we can use to solve an unknown side length or an unknown angle of an oblique triangle in certain situations. So the sine law states this for a triangle ABC. And the important thing with this is the labeling convention. So the angle here, A, capital A, has a corresponding side, lowercase a. So the angles are always capitals, the side lengths are always lowercase letters. Similar for angle B, and the side opposite B is called lowercase b, and then for angle C, the side opposite that is a lowercase c. So we can use this law, which is really 3 separate equations. So we could pair up sine A and sine B. We could pair up sine A with sine C, and we can pair up sine B with sine C. But they're all basically communicating the same thing. The letters aren't super relevant, like we could have X and Y and C in these instead. The main thing that you need to notice with this formula is you can apply it if you have an angle side pair that's complete. So suppose you had these two that were perfectly known, right? You knew that side and you knew that angle. Then if you wanted to find one of the other quantities, you'd need at least one. So suppose if you had angle C, this formula would allow you to figure out what side length C is. So the condition for this formula to be applied is you need one complete side angle pair and one of 2 of the other side angle pairs. So similarly, if you only knew side length B, you could figure out angle B, as long as you had A and A perfectly known. So let's do an example. First example number 2. Use the sine law to calculate the length of side A. So in this triangle we have angle B and side length B. We know 2 out of 2 in this side angle pair, and we know 1 out of 2 in this side angle pair. So that allows us to use sine law. So we would set it up like sine A over A equals sine B over B, and then plug in what you know. Angle A is 72. Trying to solve for A. Angle B is 52, and side length B is 16.8. So to start, we can multiply both sides by A, and A divided by itself on the left is just 1. Now we have A on the right, and it's upstairs now, so that's great. And next we should probably get rid of this denominator, so I guess we can multiply both sides by 16.8. 16.8. Now on the right, 16.8 divided by itself is 1. So now we have 16.8 sine of 72 equals A times sine of 52. Now at this point, if you want to do this multiplication, that's great. You'll get a number out of it, that's fine. And if you want to evaluate sine at 52, that's great as well. But what you need to do basically next is take this number and divide it both sides so that A is on its own. So divided by sine of 52 both sides, divided by sine of 52 there. That leaves you with 1A on the right. And you would do 16.8 times sine 72, figure out what that is first, and then divide by sine of 52. And you would get A being 20.3 centimeters. So that's how sine law works. The biggest thing that you need to do with this is stick to the convention of labeling. Capital letters are used for angles, lowercase letters are used for sides, and they're always paired opposite. So let's do another example. Question number 3b. We need to know lowercase m. We have angle m, and we have one other pair that's fully intact. We know 2 out of 2 in this side, an angle pair. So we would do sine of m divided by m equals sine of n divided by n, and then we plug in what we know. So m is 43, capital M. We need to figure out what lowercase m is. Plug in 61 for angle n, and 15.9 is side length n. So now we need to sort of bring this upstairs if you like, so multiply both sides by m. That's 1. Now we have m times this thing on the right, and now we should probably get rid of this in the denominator, so multiply both sides by 15.9. 15.9. 15.9 divided by itself is 1. So at this point we would have 15.9 times sine of 43 equals m times sine of 61. And we want to get m on its own, so we should divide both sides by sine of 61. Divide by sine of 61. That's 1. And when you do this, 15.9 times sine 43 divided by sine of 61, you get lowercase m is equal to 12.3 centimeters. And again, if you prefer to work with the numbers in the intermediate steps, that's totally fine, right? You can figure out what this number is and then figure out what this number is. So there you would basically have 10.84 equals m times 0.8746. And then you can divide both sides by this 0.8746, and you'd get the same kind of thing. I guess that should be a 12.4. All right, I'll leave the rest for you to do, and we'll do question number 4b together as well. So identify what you know. You have 2 out of 2 with f and side length f, and we have 1 out of 2 in this side angle pair. So we would apply sine law like this. Sine f over f equals sine h over h. Plug in what you know. Big F is 52, so sine 52 divided by 16.4 equals sine of h. So we don't know what h is, the angle. We know the side length though, so that's 12.7. Again, that would be labeled as a lowercase h. And now we just need to multiply both sides by 12.7 because we want to get h on its own. So if we multiply both sides by 12.7, 12.7 divided by itself is 1. So we would have 12.7 sine 52 divided by 16.4 equals sine of h. So we'll need to evaluate this now. So 12.7 times sine 52, figure out what that is, then divide by 16.4. So from that you should get something like 0.61022-ish. That equals sine h. And if we want to figure out what h is, we need to take the sine inverse of this number. So that really doesn't change from our right angle trig rules. We still need to use inverse trig functions to figure out an angle. So when we take sine inverse of this number, we get 37.6 degrees. So that's it for me for today. There's your assignment, and I'll see you next time.